Today, we're going to crack open a really powerful toolbox called multivariate time series analysis. Now, I know, that sounds super complex, but really, think of it as a way of listening in on the secret conversations happening inside our economy every single day.
You know all those big economic headlines, right? We're always hearing about interest rates, inflation, and GDP growth, but have you ever stopped to wonder how they actually influence each other? I mean, does a change in one of them create a ripple effect through all the others? To answer that, you have to stop seeing them as separate stories and start seeing them as interconnected characters in one big economic drama. And this really boils down to two totally different ways of looking at the world. For a long, long time, the standard approach was what we call univariate analysis. It's kind of like studying a single tree and completely ignoring the forest around it. But today, we're all about multivariate analysis, which is about seeing the entire ecosystem, how all the trees interact, how they feed off of each other, and how they move together.
Okay, so let's kick things off by digging into why looking beyond just one single story is so important. So what is this thing, really? Well, at its core, multivariate time series analysis is just a method for taking a bunch of different streams of data that change over time. Think something like monthly inflation and quarterly GDP, and then looking at them all at the same time to see how they sort of dance with each other. It's all about catching those dynamic relationships in the act.
So why bother? Why is this such a game changer? Well, the payoff is huge. First, you start to uncover these hidden connections you'd never see otherwise. Second, because you're using more information, you can make way more accurate predictions. And third, and this might be the most important part, we can actually start to figure out causality. We can finally answer that question. Is it interest rates pushing inflation around, or is it the other way around? To get started on this journey, we're going to begin with a really foundational tool in our kit. It's called VAR, and it's our gateway into modeling these incredibly complex systems.
So what's a VAR model? You know, the core idea behind it is actually brilliantly simple. It just assumes that everything in the system can influence everything else. The future of any single variable isn't just decided by its own past, but by the past of all the other variables in the system. It's a world of total interconnection.
All right, let's make this real for a second. Let's say we're trying to model GDP and interest rates. A VAR model would look at the entire history of GDP and, at the same time, the entire history of interest rates. Then it uses all of that combined knowledge to forecast what both GDP and interest rates are going to do next. It's a two-way street, you see.
And believe me, this isn't just some academic theory. VAR models are absolute workhorses out there in the real world. Central banks use them to figure out how a policy change might ripple through the economy. Financial analysts use them to understand the connections between stock prices and bond yields. Heck, even climate scientists use them to model how things like temperature, CO2, and rainfall all interact. But, you know, just when we get comfortable with VAR, we hit a bit of a plot twist. It's a really fascinating problem that, luckily, leads us to an even more powerful idea: co-integration. So here's the catch. VAR models have one big rule. They really love what we call stationary data. Now, all that means is data that kind of wobbles around a stable average, almost like a heartbeat. It goes up, it goes down, but it always comes back to the middle. It doesn't just drift upwards forever and ever. Okay, so that raises a huge question, right? What do we do with variables like GDP or stock prices that pretty clearly trend upwards over time? They aren't stationary. But what if two of these drifting variables are somehow tied together? What if they move in a way that makes sure they never get too far apart? Well, the answer to that puzzle is this beautiful concept called cointegration. It describes a situation where you have two or more things that are just wandering around over time, but they're still bound together by some kind of stable, long-term relationship. So even though they drift together. They're sharing the same journey, basically. And, oh man, this slide has the perfect analogy. Just picture someone walking their dog, right? The owner can wander around, the dog can wander off to sniff something. Neither one of them is staying in one place. But the leash, that's the long-term relationship. It makes sure that no matter how much they both wander, they can't ever get infinitely far apart. That, in a nutshell, is co-integration. So if VAR can't handle this whole dog on a leash problem, what can? Well, that brings us to our next tool, the VCEM, which is designed for exactly this kind of balancing act. So, let me introduce you to the Vector Error Correction Model, or VECM.
You can think of it as a smarter, more specialized cousin of the VAR model. It was built from the ground up for data that's cointegrated. And its superpower is that it can model both the short-term wiggles and that long-term pull of the leash. This table just lays it out perfectly. A VAR model is your go-to when you've got stationary data and you just want to look at short-term interactions. But the moment you have non-stationary data that's co-integrated, that dog on a leash, you need a VCM. And its key feature is right there in the name: error correction. It's constantly pulling the variables back towards that long-term relationship, just like a leash pulls the dog back towards its owner.
So why does this all matter so much? Because a VCM lets economists do something pretty incredible. It lets them analyze all the short-term bumps and wiggles while never losing sight of that long-term leash. That makes it absolutely perfect for things like GDP and investment, which tend to grow over time but are also fundamentally linked. And yes, you better believe this is exactly the kind of tool that central banks rely on to help guide the economy. So far, we've been all about predicting the direction of things. But what about predicting their stability? There's this whole other piece of the puzzle, and that's forecasting how wild the ride is going to be. And for that, we bring in the GARCH models. I mean, think about it. Knowing that a stock is predicted to go up is one thing, but knowing whether that ride is going to be a smooth, steady climb or a terrifying roller coaster, well, that's something else entirely. Predicting that uncertainty, that volatility, is a completely different ballgame.
And this is exactly what GARCH models were designed for. Now, don't worry about that ridiculously long name, just focus on what it does. It analyzes and forecasts volatility that changes over time. It helps us answer the question, how shaky are things going to be tomorrow, based on how shaky they were yesterday? This is really the heart of modern risk management.
And just like our other models, we can look at this in two ways. Univariate GARCH, that's for forecasting the roller coaster ride of a single stock. But multivariate GARCH, that's where it gets really powerful. It helps us analyze how the roller coasters of many different assets are connected. And if you're a portfolio manager, knowing if all your assets are going to get shaky at the exact same time, that is absolutely critical information. So let's just recap our journey real quick. We started with VAR to get a handle on the basic interconnections in a system. When we realized that some things wander together, we brought in VECM to model that long-term balance. And finally, we added GARCH to our toolkit to forecast not just where things are going, but also the risk and uncertainty along the way. And that really brings us to the end. These tools, VAR, VEC, and GARCH, are how economists and analysts decode the incredibly complex signals the world is constantly sending us. So I'll just leave you with this question. Now that you've had a peek inside the toolkit, what hidden connections, what new dogs on a leash would you start looking for out there in the world's data?